So how do we really supercharge the chip development using open source AI plugins for your GenAI copilots? Now, the GenAI is there, and then the copilots are really effective and to generate your code. So I'll walk you through what are the steps and how do we really leverage and what we contribute and take this drive into chip development as we go. Let's start with the industry trends, how the market space looks like as of today, and then maybe for the next 5 years, 10 years, and then how open source is going to be really, the major part, plays its key role in chip development. And of course, GenAI, how do we use code assistance to generate your code, to realize the hardware, or how do we supercharge, do the shift left, and always the time to market is the pressure in terms of chip development. How do we do the shift left? How do we save more time? And when it comes to chip development, there are a couple of segments which will be very critical and important in terms of the application and the domain that you are operating. One is the FPGA designs. Yeah, you don't want to go for an ASIC. Yes, there are segments or industry segment that is useful for FPGA designs, and we'll see how the GenAI is useful in terms of how you address that market. And then, we are talking about the metrology. UVM metrology is the de facto metrology in terms of design verification and chip development. How GenAI and then the Copilot assistant can be useful there. And the next one is the system-like assertions, which is which is primarily behind formal verification. So we'll cover that as well. And then, yes, these are the important pieces and parts of the puzzle. And then where do we go from there? So I'll be taking care of a couple of bullets, and then Shini will be joining me later to take into this deep technical dive. All right. So let's look at the landscape of semiconductor industry. So this is a prediction from one of your market analysts, where in 2025, we are staring at somewhere at 719 billions, and then it is expected to reach by 2030, 1 trillion. So the key segments are the players who are going to drive this kind of a growth is shown in the legends. The two important contributors are, one is computing, the other one is the communication. They top the list. They are going to be the drivers of this semiconductor trends for the next 5 years. All right, so that is the market TAM. Then what are the challenges? What else we want to look for? Yes, this is primarily the challenge that the focus is going to be on AI integration, like the generative AI copilots, where you want to generate your code, and how do we use that consistently, and how the AI, these assistants can be integrated into the flow of each and every company and depending on the product. So the integration is going to be a primary challenge, and that's going to be an interesting area. Of course, the automotive expansion in terms of electric vehicles, the safety is going to be critical there. How do we handle the safety part of it? How do we really adhere to the compliances of our safety standards? What else are we focusing for this kind of growth? Smart manufacturing, of course. We don't want errors. Yields should be better, and then your dollars should be saved. Of course, what we cannot ignore is the workforce expansion. How we can be more productive, highly productive, and then how do we really give the success in terms of your hardware realization using good coding, and then are we skilled enough to really go there? So the workforce expansion is also important because there is a skill gap. There is your engineers are not really equipped with what we are going to really challenge. The challenges keep on increasing. The complexity is growing every day. So how do we cope up with that? And the important one factor that we cannot ignore as of in the world today is power. How do we really go for sustainable growth? Just because, we can be irresponsible, because we want growth, we can throw away everything? No. We want to be more mature and responsible, We need to take care of your sustainable growth by achieving, the chip production for everyone's benefit. All right, so one key segment in terms of chip design is the FPGA market. Let me start with the predictions in terms of FPGA market. That is from 2023 to 2033. So these are the numbers, right? And there are three segments: the low range, and then mid range, and then high range FPGAs, based on the application and then what kind of power and performance that you are expecting. And also in terms of monetary, right? It is the market segment in terms of FPGA is around 39 billions. And it is looking good with the CAGR of 13.6. If I assume some of you are hardware engineers who are familiar with the flow in terms of FPGA. If you start your product specification, from there we go through different phases of chip design. Okay, this is day-to-day job. There's no surprises there. Yeah, so I don't want to really take your time to really explain what that is. So this is what our daily chore is. All right. So what is unique about FPGA? Yeah. So the challenges are different. Is it same as ASIC? No. Even though they are hardware that goes into your chip, that goes into your all your smart devices, but the challenges which we face in FPGA is different from ASIC. That is the key factor that you need to consider. And what else you want to think about? So the moment you mention FPGA, the resources are important because you want to save area. Right? You can't put the entire hardware. It's up to you. You want to use it wisely, or you just want to really consume everything, right? Eating your boundaries. Okay, no, the board is not enough. Is that what you want to face, or you want to say, hey, no, I've utilized only 20%. Is that good enough? So when you talk about resources in FPGA, so there are LUTs and block RAMs, and then DSPs and mega functions. These are the features typically we come across in FPGA design. Is it effectively used? Are they optimized? All right. So what feature and what configuration, how do we really go for effective implementation of FPGAs? The knowledge deeply lies within the team, within companies. These are all, I would like to call it as non-transferable knowledge, which is missing in your current GenAI assistants. It generates code. Yeah, compile free, nice, it looks nice. You can read it, yes, syntax-wise is correct. But does it really take care of the deep tech that is lying within the team, with the knowledge, and then really, they know the best. If there is something hanging, okay, this is a feature for this product, that lies in our engineer's mind, not in the code. All right. So that is how the top level, the landscape looks like in terms of FPGA. So what are the challenges in your FPGA design? The moment in any of, we mentioned FPGA, it is PPA, the power, performance, and then area. Okay, am I using my resources well? Okay, my performance is met. Is it really handling it, or is it burning, right? Is it areas effectively used? And also the power, is it less? Okay, what if, I don't care about any of this. I just write a code and then burn it in your board. Yeah? You end up with a hardware which is going to consume more power and more area, right? It may run very slowly, right? You want to really pick up the phone and then take the photo as well as send it fast and then talking to somebody else. That is not the speed that's going to work. All right, so the complexity increases. So that means the performance is, the demand on the performance is high, so you need more area. All right, so is that enough? PPA is enough? No, based on the applications, especially, when it comes to space grid. Is it the same as your data center? And you're talking about, your devices in Moon, Mars, that is not going to work in your data center. And then your data center hardware is not going to really work there because no one knows what are those conditions. Temperature is different, power is different, everything is different. So you can't expect, So that is why the application-specific FPGAs or that knowledge center or those configurations, those parameters are different. All right, so we agree on this. We set this base, very nice. Okay, how do we implement, right? How do we get the hardware? That is, at the end of the day, you have to really write your code. That depends on which coding style that you are going to use. It heavily depends on your coding style, right? So you have to really intelligently use your coding style that makes impact in terms of PPA. And for sure, in my experience and my team's experience, I can share that the FPGA coding style is completely different from ASIC. Even though it is hardware, it is not the same. The way you write your RTL code for the FPGA is going to be different. Okay, so these are the challenges. How do we handle it? All right, I'm here proudly to claim that, okay, open source is going to be the rescue. All right, okay, so what is this build your own linter? That is what is going to be the supercharging, right? Supercharging your chip development using your copilots. That is going to be, right, based on your open source. Build your own linter, that's going to be the plugins. Okay, so at the end of the day, you need to realize the hardware. You are going to use your code. So how do we really qualify those codes? Because, you have the hardware, you use your GenAI, right? Okay, that creates your code. Is it enough? Okay, is the code is going to really, right, achieve me the hardware that I'm planning to? So for that, you need your own custom linters. Okay, that is where the open source comes into picture. Targeting your Altera-specific or Xilinx or AMD or Actel, so that which is specific to that FPGA family. Okay, this is hardware that I'm going to use it. Okay, so let me stick to the rules and then discipline that is targeted for the particular FPGA family. All right, so when it comes to EDA tools, commercials are really high, and then that is for everyone, right? So one size is going to fit for everyone? No, I need my own styles, design styles, coding styles. These are the specific parameters that I want to check. So those things can be, right, implemented as your own linter. All right, so yeah, we have the linter. Okay, how do we use it? Then the build your own linter will be really, right, useful in terms of your standard flows and the development flows, the check-in, the right continuous integration and continuous development. So you put the linter as part of your development flow, which will take care of your quality of your code. So hopefully, right, this knowledge or the entry level for the right workforce will be useful to really, right, build your own linter. Good. When you talk about GenAI Copilot assistants, there are 4 major tasks you can think of while deploying your copilots. One is code generation, then code reviews. What else? Refactor. Code refactor. Okay, yeah, we have some code generated. Okay, no, I don't like it. Can you give me, right, a better code? Yeah, we can refactor those codes. This is a piece of code that I don't write. I feel that it is not really up to the mark. Okay, let's go and refactor it. We can do that. And it's not only that, you can do a deep technical analysis using this GenAI, right, assistance. But it's up to you which application which problem that you are going to solve. Okay, let me walk through you a couple of experiments that we have done, and then show a couple of examples on how we can supercharge the chip development using your GenAI assistants. Okay, so as an hardware engineer, this is where we start. Okay, I tried this one. Okay, I asked a copilot, okay, saying, okay, create code for this block. So in this case, it's FIFO. It has done a very pretty good job saying, okay, yeah, here is your module, that is your synchronous FIFO, and then all the RTL that goes into it. So far, so good. It's very nice. It has done a very decent job. All right, so I'm done with the design. Okay. Typically, the next task is we develop a verification code at the test bench to verify that RTL that is, right, it's working properly. Yeah, good. So again, it has done a very decent job. Okay, saying, okay, typically, if you're familiar with, there's a test bench, clock generator, and then test case. That's a flow. But he generated a clock. This is a piece of code that is relevant for the clock generation. That's a basic one. It is not really scalable for jitter, or if I want to add additional parameters, that's not the way. So I gave another prompt saying, okay, use go-to-UVM package, but that is our open source contribution and then package. Then I asked, okay, now generate the code for clock generation. It has given me a better code. Okay, this is a clock generator with a frequency and then other things. So it gave me, basically, the generative code is based on your prompts. What you ask, that's what you're going to end up with. So you have to keep on trying. You have to iterate it. Okay, give me the code this of that. Oh, no, I don't like it. Okay, go on, improve it. So that is a problem, or that is a hole in terms of GenAI. Right now, it creates very clean code, but anything deep tech or the technology, knowledge, the technical knowledge that lies in terms of language, methodology, as well as domain, that is missing. That is where our plugins comes into picture. So yeah, it's up to you whether you want to leave with the code that is generated universally for everyone, or you want to really fine-tune the code that is going to really achieve what you want. All right, so now the test bench is there. Then I asked, can you give me a test case? Basically, it is for a FIFO. I want to check full and then empty condition. And FIFO full happens when, you just keep on writing and see how many writes, and then whether the condition is going to matter or what happens. So I asked to write a test case. It has done a pretty good, decent job. All right, I'll take a break and then I'll hand over to Srini to take this forward.
Thank you, Ajita. So my name is Srini, and I'm the founder of Asfigo. And thank you, State of OpenCon. Last year, I was also lucky enough to present the previous generation of the same technology. Now, we are, of course, supercharging and GenAI assistant with the same technology. That's where we are. And as of today, most of you know that Altera spun off from Intel to become an independent, the largest independent FPGA company, as they call it. And they've also announced this Altera Solution Acceleration Partner. It's called ASAP. And we're just lucky to be part of that now as we speak. It's literally a day or two old news, so we are quite excited. And the reason why we are here is up there. So when a customer says, okay, now the design, as Ajita just said, the GenAI today can generate a code in a matter of literally seconds, if not seconds, minutes, including your prompting time. If you go and say, okay, I want this, I want this, I want this, it's a gigo, garbage in, garbage out. If you know what you're asking for, which I think the Brit should be really, really capable of doing. So there is no real big surprise that you can actually get code out of a code assistant today with very little effort. That kind of is done, especially for small blocks. Now, the real challenge happens is when you actually want to target to a specific FPGA, and that knowledge is missing today with the code assistants. What do we mean? Let's say I want to have a specific Max 10 as my target device. Max 10 is one of the FPGA families from Altera. Right? And that's actually a volatile, that's a non-volatile, that's a flash-based FPGA. And there are specific coding styles. For example, one vendor prefers as in the hardware, the FPGA, some of you, I'm sorry if I had used the acronym straight away, it's called Field Programmable Gate Arrays. And there's a very good reason why they say that. There are enough, let's say, it's like building a Lego, right? So you're given the pieces, you can stitch them together to make something that you want. You could build an elephant, you could build a bear, you could build a Paddington bear, whatever you want to do, right? Now, however, nothing comes for free. If you use an asynchronous reset, one set of FPGAs work very well. The other set of FPGAs, the other family, let's say from Xilinx versus Altera versus Actel, one of them probably doesn't natively support it, so you got to add an AND gate or an inverter at the front to make it, let's say, asynchronous versus synchronous, etc. Mux, yeah? If you think about it. Now, that impacts because for every flop that is getting reset, you're talking about adding a mux. And for space-constrained devices, this becomes a big thing. So the PPA starts getting impacted right away. The same RTL you want to use with different FPGAs, you want to do it slightly differently. The same thing goes for FSMs, finite state machines. Do you want to reset every flop in there? Technically, in an ASIC world where I come from, I started with ASIC back in 96, 97 timeframe. That was the golden rule. Do not worry about it, just reset everything. If you do not reset, something will go wrong on the field. Now, fast forward, you start getting into FPGAs, they say, no, don't do that. Because you're going to consume additional resources. With FPGAs, you get this idea of power up. And adding on with the flash-based FPGA, you also get for free a retention. What is that retention? Essentially, when you power down, let's say with that system you were taking a picture and the DMA wasn't transferred, it actually is powered down. When you power up, it's going to come up exactly in the same state. That's because there is a non-volatile memory in which the state is saved by the FPGA by itself. That's the device architecture. Now, we could actually then, you got to design your RTL in such a way that if you're going to target a flash-based FPGA, you got to be aware of the reset states and then accordingly code them. So the RTL code should be designed accordingly. Now, imagine a VS Code plugin, assuming most of you use a VS Code. Again, nothing specific about VS Code, but it's just that it's so popular. A VS Code plugin can be tailored to such specific target. That's what we're talking about, the code that Ajita showed. Now, if you say, okay, there's an additional customization in which you could say that I'm going to target a max 10, so accordingly generate the code for me. And that's what we are trying to provide through the ASCP. This is just work in progress, so I'm going to skip that part, ASCP part. Okay, so far so good. Switching gears, we move on to the verification side, which has been my expertise for a long time. And I'm also a designer, but primarily a verification engineer. So we started with the standard one because we live in Britain, and ARM is really the poster boy from UK. Most of us use these devices. All our mobile phones contain one or the other or more of your ARM devices, ARM IPs, right? So we go and say, okay, now GenAI, go and give me an APV interface for me. For those who speak the language, it's easier. Otherwise, don't worry. The syntax is correct. It says interface, da-da-da, and then it gets you a clocking block. Beautiful, in my opinion. Now, somebody might come and say, do not shout at me. Especially in England, I learned this, right? So do not do this way. I prefer it in one style versus the other. I could use a camel case, a snake case, a Pascal case, so on and so forth. That's really your style. You want to stick to it. And you do not want, just because you're generating some code from a GenAI assistant, you do not want to violate your coding styles that you have set for a long time. So you could actually tweak that. And how do we be consistent? Of course, you could prompt it. But instead of prompting, we are going to supercharge with a linter. The linter comes and assists the code generator to say, the code generator, before it actually dumps out the code, it consults the lint rules that your team has come up with, and then accordingly, it generates the code for you. So every time you generate, you're going to get consistent code that is tailored to your style. That's really a starter. Let's go into something a little bit more meaty. Let's look at, now that we have the interface ready, I said go and generate a UVM monitor for me. For those who speak UVM, pardon me, I'm going to expand that. Universal Verification Methodology. That's an IEEE standard by now. Started as an Accelera standard. There's a long history to it. There's an ERM, VMM, OVM, etc. But fast forward 2025, we have IEEE 1800.2, which is an UVM standard, right? Now, this guy generates, okay, there's a class monitor, extends UVM monitor, all this code is nice, and it's also very well indented, etc., etc. And it has a run phase, all good, but suddenly look at this, it starts putting postage of whiff.clock. And for those who do not believe me, there's a gentleman named Dave Rich, if some of you know him. He works for Siemens EDA, Mentor Graphics, and they run this forum called Verification Academy. And if you go on, there's a nice user forum out there. There, you would see why you do not want to be doing this. It's going to be race prone. It's going to be harder to debug. And also, let's say the same test bench, you want to use it with a gate level design. And all you want to do is, let's say for whatever reason, you want to drive it on neg edge of clock, or in this case, sample on the neg edge of clock. You will have to change at n number of places if you do this way. So there's a big rule on the UVM linter that says avoid edges inside the class. Instead, use clocking block. So you should always use a clocking block-based synchronization than an edge-based synchronization. That's a lint that we have with the UVM lint. Now imagine that you could actually ask the VS Code plugin to go and say, make sure this rule is never violated when you generate the code. Again, it technically can be done by one prompt at a time, but this is what we call a supercharging. We know what can go wrong, we code them as lint rules, and then we provide it to the GenAI. Excuse me. Next example. Again, some of this, by the way, when you try, you might get slightly different result because of the so-called hallucination, and it's not 100% reproducible, unfortunately. But again, that's where the supercharging helps. With such custom rules, build your own linter, and then plug it in, you are almost guaranteed to get consistent results with it. Let's take a look at an example of an agent. And this agent, unfortunately, today the terminology of agent in the context of AI is quite different. Whereas in the UVM world, it's actually a reusable piece of code. It's called the VIP, Verification Intellectual Property, or UVC, Universal Verification Component. Let's say I generate a APB UVC. It goes and generates all this, the monitor that we just saw. Everything is good in there. There's a build phase. All this is beautiful. However, it misses a very important topic out here. I'm not going to go into the UVM training per se here, but for those who look at it, stare at it, and then they'll tell you that, hey, you're not checking for isActive equals UVM active. And if you do not do that, your code is perfect for your use case. The moment you want to integrate this UVC to the next level of verification, let's say vertical reuse, and you want to make this agent passive, you cannot do that. You're going to spend countless hours of debugging this. The code actually compiles and runs for that particular user, but when you integrate it to the subsystem verification environment, the code doesn't work anymore. And that kind of rules, again, you do not want to be thinking later. You want to supercharge your GenAI assistant with such important rules. Now, let's change the next topic, which is now that we looked at a couple of examples of code generation and how a custom linter can help you with that process. Let's look at code refactoring. And in this case, we started using Amazon Q developer. Also because I like the Bond movies and the Amazon Q, the Q sounds Q, right? So we all like it, we all love it. So now I said, okay, here is my code. I go and do refactor. So over here, you say refactor this. Let's see what it does. So the first thing, of course, it explains and all that. First thing it did was it actually made all of them protected, which the strict OOP guys would love it, because now I protected my variables from being publicly accessible. Right? We provide an accessor routine to access, set, or get. That's kind of what the coding guidelines coming from the software world. Unfortunately, many of the hardware engineers, including myself, we do not do it all the time. Right? There are good reasons, probably because there's too much to type, because you can see that I got to actually add 4 or 5 lines of extra code just to set a value. I'm too lazy to do it, but thankfully with the GenAI, we could actually generate this code. That's a good thing, right? So that's what I did. In a minute, in less than few seconds, it said, okay, here is your refactored code. Don't worry if you don't read this text, it's probably too small, but let's expand that. Now, let's look at how it did. We looked at the UVM lint rules. So the method shall be virtual. To begin with, these methods are not declared virtual. The second is it also misses the get accessors, which means this code is going to be harder to debug. I mean, you have access to it, but you cannot do a print or a dollar display of that particular, let's say, variable, the default address, the default data, so on and so forth, from external world. If you want to do that, you got to have the get accessors in there. Again, imagine that basically what we are going to do as a rule is, if there is a protected member, for that protected member, you need to have both set and a get. That's a rule, for example. So the next, continuing with it, it said, okay, here is your task body. This is now, why do we need UVM lint in GenAI? This task could be, some teams might say, I want to use always external methods. That's a rule, if you want. Again, these are not hard and fast. You could choose, pick and choose the rules of your interests. But that's one example. The other example is, there is a repeat loop, there's a for loop, there's a while loop. for most of us who have been doing this, repeat loops are a little difficult to debug because there is no iterator available for you to print and so on and so forth, right? So we would probably, some teams might say, I don't want to use a repeat loop, I want to use a for loop. That's again a very small tweak. You could do the lint rule and plug it into your supercharger, and then you're done. Every time you generate a code, it's going to use a for loop. Functionally, it's the same thing. Next quick one. This is a very specific UVM rule, wherein if there is a constrained random generation failure, if for whatever reason the address could not be constrained to the address that you wanted, throw an error, which is fair enough. However, in the UVM library, the so-called IEEE, the core library, it uses this specific API called the UVM warning with the RND-FLD, that I believe stands for randomization failed. Now, it will be nice to have the same API, same consistent ID when you report randomization failure. So one user came and said, I want to make sure wherever I have this piece of code, it should be UVM warning, then an UVM error. You want to do that? Again, plug it in as a rule, make sure you get consistent results with your GenAI. This is my favorite because this is something that is like few days, probably 2 weeks back, a story. The story goes here. This is about the code review. A fresh grad, pardon me saying that, but probably you look like a fresh grad out of college. You go and say, I'm learning UVM, I'm writing this code, it all looks good, but I have a, I'll make it faster. So essentially what happened, and the link is out there, the code started hanging right after reset. Up to reset it works, out of reset, I'm not saying you will make that mistake, but somebody made a mistake, and they said, can you help me debug? Now what we did was we took that opportunity to feed that code to a GenAI, and then say, hey, go and review it. Initially it did nothing, then it did a lot of stuff, but none of that coming close to what the real issue was. Again, I'll be available outside if you want to talk in detail, but this data is available on the web in the Verification Academy. And essentially he said, when the reset is asserted, the test bench works, but as soon as reset is de-asserted, the simulation gets stuck. And it's definitely nothing to do with you as an individual. Most of us, even 20 years, 25 years, we face this problem, right? There is a zero delay loop somewhere in your scoreboard, just that you don't see it, and you want an additional pair of eyes. That's usually it used to be your seniors. Now it could be your GenAI, right? So essentially what we did is, basically there is a problem, this is another gentleman who provides a lot of interesting stuff, and then he says, let's not use signals straight in the scoreboard because that's known to be a problematic area. And that's what we have in the UVM lint. It goes and says, do not use a virtual interface. That's one rule. And then UVM info, you don't need a dollar display with time with it, so on and so forth. So essentially, this is what I replied. This is my user ID. It hangs because of you have a virtual interface which is not checking for right things. So, fast forward. We could also use it for formal verification. I'm going to go a little faster. This is an AXI example wherein we could actually use an assertion IP to formally verify. And what we did was we took this code and said, hey, go and review this code for me. It said, okay, it's all well and good. You're good to go. This is one copilot. The other one, it came and said, okay, you are missing, you could potentially add assumptions. That's really the issue. What we did here was, with our technology, we started analyzing it and said, look, if you want to use this assertion code with formal verification, you got to have assumptions and covers. Because without that, assertions make no sense in a real formal verification world without constraints. That's why we actually provide this as a quantitative analysis on your IP, and this knowledge can now be fed to your GenAI assistant to review your AIP and come and tell you, is this AIP formal ready? Does the FPV tool support, for example, if you may be using one tool like Jasper, VC formal, whatever, right? And then, does it support all the constraints that are generated or in there in the code? Are there any potential dead ends to debug, like say deep memories, excess, etc.? And then, we can also, how do we debug the formal verification traces? We use something called a YANAS. I think pretty much we are there. So the last two slides on how do we integrate this with both the Copilot, the two popular examples today, the Copilot and Amazon Q. The next one is work in progress. This is kind of done for a specific customer, wherein we could actually add it as a custom agent. This was done for the FPGA use case that Ajita was alluding to. And in this examples all come from Microsoft and Amazon, nothing from us. But just that we provided
and UVM lint as a customization. In Amazon Q World, specifically what we are doing is we provide a JSON file, and the JSON file becomes part of your RAG, and that knowledge itself is with the end customers. I'm done. Thank you. Thanks for listening. And any questions, we can talk it here or outside if we don't have time. Thank you. Appreciate it.